We're surrounded by this entire miniature world, just teeming with life that, let's be honest, we usually just walk right past. But what if you could actually understand that world? What if it was as simple as just pointing your phone? Well, today, we're diving into a brilliant new AI that basically puts an ant expert right in your pocket. Now, I'm serious. Just think about that for a second. You're out on a walk, you see a tiny little ant marching along, and you could just pull out your phone, snap a picture, and instantly know what it is, its scientific family, its genus. I mean, it sounds like something straight out of science fiction, right? But it's way closer than you might think. And the answer, the thing that makes this possible, is a really powerful new AI application called the Formicidae system. It's designed to do exactly that, to put a mycologist, which is just a fancy word for an ant expert, right there in the palm of your hand. So at its heart, what we're talking about is an AI that's been built for a very specific and actually a very tough job. It has been trained to recognize and identify 235 different genera of ants from all across the globe, just from a single picture. Okay, so how does this actually work for somebody like you or me? The real beauty of this whole system is just how simple and elegant it is on the surface. From your perspective, as the user, it is incredibly easy to use. It's really just 3 simple steps. You log in, you upload a photo, or hey, even a video of the ant you found, and that's it. The system takes over. It processes the image, it draws a little box around the ant, and then boom, you get an identification, and it even tells you how confident it is in the result. And the performance of this thing, it is just astounding. Under good conditions, with a nice clear picture, it can hit an identification accuracy of up to 90%. That is seriously, seriously impressive for a task this complicated. But that slick, simple interface is hiding a really big story. A story of a massive technical challenge. Because building this was anything but easy. And the problem they had to solve is one that honestly plagues a ton of AI development, especially in biology. You see, the real challenge wasn't the AI model itself. It was the fuel that the model runs on, data. Or, in this particular case, a critical lack of data. To teach an AI to recognize something, you need thousands and thousands of examples. And for a lot of species out there, those examples just don't exist. Let's just look at the numbers for a second to really get the scale of this problem. In the entire world, there are 333 known living ant genera. So that's our target, right? That's the total group you'd want the AI to know, ideally. But when the creators went to a major database for biological images, they found photos for only 273 of them. I mean, right off the bat, 60 different genera had literally zero photos to train the AI with. They were completely invisible. And it gets worse. From that smaller group, they had to toss out another 38 genera because they had fewer than 10 sample images, which is just not nearly enough to train a reliable AI. So their huge starting pool of 333 was just whittled down to 235 that were even trainable, all because of a lack of data. Now, the data they did have was also super unbalanced. This is a classic problem in biology, something called a long-tail distribution. All it means is that you have tons and tons of pictures of a few really common ants. That's the head. And then very, very few pictures of most of the other rarer ants. That's the long tail. And this chart just illustrates the problem perfectly. I mean, look at this. One singular genus, Camponotus, had more than 220,000 photos available. Meanwhile, you had over 216 other genera that had fewer than 10,000 combined. If you tried to train an AI on that, it would get really good at spotting Camponotus and be absolutely terrible at everything else. So this brings us to the absolute core of their innovation. What do you do? How on earth do you teach a machine to become an expert on something rare when you have almost no photos to show it? Well, the solution, and this is where it gets really clever, wasn't to go out and find more photos in the real world. It was to create them in the digital world. And they did it using a technique called data augmentation. Data augmentation is such a cool concept. The easiest way to wrap your head around it is to think of it like putting a single photo into a digital funhouse mirror. You're basically going to create endless new, weird, warped versions from that one single starting image. So here's how it works. You take that one precious photo of a super rare ant, and then you digitally stretch it, you flip it, you rotate it, you change the color a little bit, you adjust the brightness. You do all this stuff to create thousands of brand new, unique images to train on. You're teaching the AI what that ant looks like from every possible angle and in every possible lighting condition. And the impact of doing this was, well, it was transformative. Before this whole process, they had about 120,000 images, all heavily skewed towards those common species. After augmentation, they had a perfectly balanced training set of 235,000 images. That's 1,000 images for every single genus. It's incredible. I mean, just let that sink in. They digitally manufactured almost half of their entire dataset. The source material actually notes a 48.9% data augmentation rate. They literally created knowledge out of nothing, out of scarcity. So, okay, this is a super cool ant identifier. But why does this matter so much? Well, because this story isn't actually just about ants. This technique, it provides a powerful blueprint for tackling some of the biggest challenges in all of science. Think about it. This exact same method can be used to identify other rare insects or plants or any animal that faces that same data scarcity problem. It's a tool that can empower citizen scientists everywhere to contribute meaningful data. It could dramatically speed up biological research. At its core, it's a way to overcome one of the fundamental limits of modern AI. And this is just the beginning. The team behind Formicidae, they've already confirmed they're developing more of these species recognition apps. So what started with ants is getting ready to expand all across the tree of life. And that leaves us with this final, really exciting thought. By using AI not just to analyze the data that we have, but to creatively overcome the data that we don't have, we've basically opened up a whole new door. So what other secrets of the natural world are just out there, waiting for the right algorithm to come along and unlock them?